So you should have filled this out. These are the numbers. If you need to pause it, take a look at it to get the numbers if you don't have these exactly. What you'll see is all of these, this is all 2 to the 10th power is 1024, and 2 to the 7th is 128, and those kinds of things. So what we're going to be working on is getting these bases instead of these numbers. Okay? And so then we'll solve the equations that we did yesterday. Alright, so this is how it works. You have 2 to the x is equal to 8. What you need to do, isolate the power if you have to. That means if this 2 to the x wasn't by itself, if there was something added to it or multiplied, you get rid of it first. Write each term as a power with the same base. So what you do is you look at, I can't go back because this is just the way the program is, but if you look at it, you know that 2 to the 3rd power is 8. And then we have a base 2 here already. So we can get that so that the 2's are the same. So what you look for is the answer, not the base to begin with. You look for the answer to be the same here and here. So you know 2 to the 0 power, it was up a little higher, is 1. 2 to the 1st power is 2. So the answers, you have to find the 2 answers here and here, that those are the same, and then we rewrite them. So 2 to the x doesn't have to change, but 8 is 2 to the 3rd. Now the bases are the same, we can simply drop them and finish that. Alright, so it works out the same. So you look and you find, so this is what I'd like you to refer to, your answers. So if you look through it, you know it's 2 squared is 4, and 2 to the 3rd is 8. So you're looking at that chart as you follow along. So we rewrite this 4 as 2 squared. So just rewrite it as 2 squared. And then the a goes right next to it. It is multiplication because it's going to be power to a power. 8 is 2 to the 3rd. Now instead of putting parentheses like this, which can be somewhat confusing, I like to put parentheses like this. Now it represents this exact same thing, but it just reminds you that you're actually multiplying. And the parentheses the other way tend to confuse sometimes. Then we just drop these and we solve. Okay, so 2a equals 3a plus 3. Negative 1a equals 3, and a is equal to negative 3. Okay. So this one, you see that there is a number connected to this 7 here, so that's bad. So what we do is we need to get rid of it first. So we need to, whatever is being raised to the power needs to be by itself. So if we look on this side of the equal sign, we see that this 3 exists, so we got to get rid of it. So I subtract, because we're adding here, so we change its sign and add. And then we drop our bases. So remember, that's 7 to the 1st. The bases are exactly the same here, so we drop it. X minus 1 equals 1. So x equals 2. Alright, looking here, I may have to look at a different column besides 2's. So what we do, look at another column, see if you can figure out what the base is. So 5 squared is 25, and 5 to the 3rd is 125. Okay, so what we do is we take the other thing and put it in its spot. So 125 was 5/3, and that x minus 1 is going to multiply, and the 25 is 5 squared. The bases now get dropped. 3x minus 1 equals 2x, and you solve. Negative 1x, so divide by negative 1. Oh, sorry, that should have been a 3. So divide by negative 1, and you should get positive 3. So remember that what I just forgot right there was when you distribute that negative through, this should make this a 3. Okay, so x is 3. Here we go. What we get here is we get exponents with fractions. These are easier than they look. So let's go through it. What I like to do is I look at, and I forget that there's a 1 up here, and I just look at the 3 and the 9, and I try to find the base that would go along with this. Well, 3 to the first power is 3, so that goes with that, and 3 to the second power is 9. So I replace them. So pretend again like that 1 over isn't there, and this is just 3 to the first power and 3 squared. Now let's deal with the 1 over. So this is 1, so this means this 3 is in the denominator. When you have something, written as a fraction, you know that we can take this and make this a negative. So that's all we do. If we have 1 over something, we just make it a negative and we're done. The bases get dropped and we get negative x, or negative 1x, equals 2x minus, that happened, equals 2 minus 2x. I'm distributing in there. And we solve. So I'm going to add my 2x. And I get x equals 2. Because this is positive 1, and we're left with that. Okay, same deal with this one. Again, look at the bases only. Forget that this is over 1, and find out that 5 squared is 25, and 5 cubed is 125. So rewrite that appropriately. So 25 gets replaced with 125 gets replaced with 5 cubed times x plus 1. And 25 gets replaced with 5 squared times x plus 1. So the problem here is that this was a fraction, so let's deal with that. We just make it negative. This means this, the negative. Drop the 5's, negative 3x minus 3. We're distributing in here. 2x plus 2, and we solve. So I'll add my 3x, so we wind up getting negative 5 equals 5x, as long as I didn't make any stupid mistakes, and we get x equals negative 1. Same deal here. We got 1 over 32. So we're looking at just the 32 and just the 2. Well, 2 is his base, so we're just going to leave that alone. 32 is, we got to look for a base of 2. So where is the answer 32? Well, it should be 2 to the 5th. So this is 2 to the 5th, and since it's a fraction, this becomes a negative. Drop the 2's, negative 5 equals 2x minus 10, and we solve. Okay, so then you get 2x equals positive 5, divide by 2, and x is 5 over 2, or 2.5, however you want to write it. All right, have a great day.